teeny bit ahead of the curve on this one.
You are. So
I'm happy to be.
I have to start with the same question I asked you last time.
Bring it on, sir.
And that has to be to please explain to me, because I don't know the answer to this question of how we came from monkeys.
Okay. So the first thing that's not the first time I've been asked that.
Yeah.
People say that and use that kind of flawed logic as
because there's that stereotypical picture that shows a monkey on all fours standing up to be a human being.
Yeah.
And people get the idea that that's how we evolved from monkeys.
Right. And the first thing I will most definitely have to say is that we absolutely did not evolve from monkeys.
That's blasphemous. I don't know if I'm I don't know if I'm going to accept that.
The explanation is that monkeys and humans arose from a similar ancestor, or from a parent ancestor.
Okay.
So we have, if you think of it as a tree, we have branched off on a different branch of the tree at a certain point back in time. If you think along the lines of what the tree of life would look like, if you will, when you consider all of the species that are present on our planet today, they would be present on a web or a tree, if you want to look at it that way.
Right.
It's a good way because there's like a trunk, and then it branches out onto a few different limbs, and then it just keeps kind of spreading, and it turns into basically an exponential kind of spreading from the center.
It's never going to converge back into a certain point. It's always going to spread out.
Right.
Unlike, I wouldn't say unlike in that case as a web, but a web just doesn't, it seems like everything's still connected in a web, rather than it having a central point that branches off. A tree is just a better illustration.
That's why they call it the tree of life. Sorry. Yeah, I get it. No, the web is like it's just a different kind of way to get somebody to picture it in their head, if you want to do that way, because a lot of people learn better when they can actually picture it.
Yeah, I'm way more of like seeing things on paper, like a visual learner. Sorry, I just couldn't think of the term there. So how do you think that we have kind of evidence that we have evolved from something else?
Well, there's to say we don't really have actual evidence of macroevolution, and that's the general problem that people run across when they don't believe in it. Because the only evidence that we do have, since we can't observe it happening because it happens over such a long period of time,
right?
The only evidence that we do have is in the fossil record, and obviously the fossil record is spotty because fossils are not easily came across,
right?
They don't happen all the time.
Yeah,
it's under very special circumstances.
Right. Things aren't easily fossilized,
right? So inherently, that's a tough thing for people to get around, and that's even within the scientific community, the basis of macroevolution is under debate. It's not, most people just I don't want to say assume or believe. Most people in the scientific community trust that the mechanisms of life that they see in microevolution somehow extrapolate into macroevolution.
Okay.
So it's not the way that microevolution and macroevolution are connected is not something that's solidified in modern science. Not yet. There's a lot of theories that people use to connect them.
So we kind of see like the small differences that happen from maybe generation to generation, or even in a shorter time period than that, and then we just extrapolate that out to basically assume or conclude that we came from something that maybe not be exactly like what Homo sapiens are today.
Right. And like I said before, it's really tough to prove that we came from actually unequivocally prove that we came from another species, because the fossil information is so spotty and we can't directly observe it. So inherently, we're probably never going to get the proof that creationists are looking for.
Yeah, to definitively say that, we did evolve from something rather than we were just put here as humans and we've never changed since then.
The only thing I can say is that macroevolution has been all but proven. There are scientific papers that talk about the potential macroevolution in different viral families or virus families. So in RNA-based viruses and in what they call retroviruses, which retroviruses are they're a type of virus that injects their information into another cell's DNA. So not all viruses necessarily do that.
Right.
Other ones basically will just take advantage of the way that they replicate and make them replicate the viral DNA rather than their own DNA, instead of actually interjecting the DNA into their DNA sequence.
That's interesting.
But yeah, some viruses are DNA based, some are RNA based, but macroevolution is basically proven in RNA viruses and retroviruses.
It seems like somebody's argument may be that, you know, it would seem that humans have been alive long enough to notice a vast difference among the generations that we've been alive.
Yeah.
But I would have to, you know, any sort of argument against that, I think, would just be that, you know, humans have only been alive for Homo sapiens, I should say, not like humanoid type creatures, but we've only been alive as we are for like 200,000 years, maybe.
Like 250.
Yeah. So the what we are now is the smallest, tiniest blip of information across the whole time span of the Earth itself.
Right.
So I don't think we necessarily do have that information to see how humans may change over, you know, millennia versus.
Right. And that's a really crazy thing to try to really picture that or encompass that idea in your head, is the idea that 250,000 years is a blip on the cosmic time scale.
Yeah, it's nothing.
Right. And 250,000 years, if you think about it just on surface value, that's a lot of generations. That's 2,500 generations, you know?
Yeah, and it's even a small blip of time, like I said, just in the scope of the Earth itself. You know, I mean, it took millions of years just for things to evolve into, you know, multi-celled organisms, however that may have happened, and then evolve to what we have now, like talking, standing, thinking human beings that can reflect on their own, you know, memories and consciousness and things like that.
And one thing that I kind of glazed over, grazed over. I glaze over things very often. You know what I'm saying?
That was good.
Oh yeah, but I grazed over the whole the virus evolution thing. Microevolution, I didn't really explain the difference between micro and macroevolution, and I was going to say that the reason I talked about viral evolution is because those are the things that are most readily observable when we're talking about evolutionarily.
Micro is?
Micro is observable and provable in a lab setting.
Gotcha. Because it happens on a shorter time span.
And especially with viruses, because viruses have a very short incubation period, and they basically rapidly adapt and or genetically mutate. Yeah,
and is it because there's so many? I don't know how to. You know, a virus can just spread so much that even if a lot of it's killed off, there's just so much of it going around that it can spread so much easier.
Right. And if you think about viruses that have been eradicated in the past, like the smallpox virus.
Yeah, or whatever happens when polio. I was going to say when people sit in a wheelchair with the blanket over their legs, whatever that's called.
Right. And like the flu virus, for example, that's the best example. But they evolve to be able to get past the vaccines that we currently have, which are pretty much based on one type of virus, because they inject a small amount. If you don't know what a vaccine is, it's basically a small amount of the sickness that you're
to let your body
prevent.
Right. You let your body kind of adapt to it and fight it off and learn how to accept larger quantities in the future if it comes along. Yeah. I was gonna say it seems that like you could just basically have the argument that you know, that they're, I don't know, I can't think of exactly how to word what I want to say, but you basically just don't want to, or people just think if you kill a virus, sorry, I'm stumbling on, but I just can't think of the right words I want to say for it. That's but if you think of like killing a virus, I don't know, a lot of people think like it may never come back, or, you know, how could it transfer from one person to the other if we constantly got vaccines and stuff for it?
Right.
Sorry, but it's because it constantly mutates and changes. It's not like a, you know, a virus is just like, well, they figured it out, now we have to change and be something different. You know, it's constantly just like people in general, like we have mutations, and that's just how it literally becomes something different to where we have to get like a new flu shot every year and things like that.
And it's a similar kind of situation with even bacteria. Think about the antibiotics that we have to use. Like, I don't know if any of you know anything about antibiotics, but especially in our meat industry, it's been phasing out as of late. But antibiotics include something that's it fights specific bacteria, and those bacteria can grow immunities to those antibiotics that you're using.
Yeah.
And that's an example of microevolution. It's a change in the population genome.
Exactly. I think it's just one of the easiest ways to recognize that things adapt and evolved and change.
Right.
And how can how could you ever sit there and say that things have just always been how they have always been? Then we would just need one flu shot and then we would just be good forever. We wouldn't have to get them every year.
Right.